Hey, welcome. So let's just jump right in. When we picture our planet, we usually think of this huge, solid rock just kind of spinning through space. But what if that's not the whole story? What if, right under our feet and all around us, the Earth is constantly moving? Not just spinning, but flexing, pulsing, and yeah, even breathing? Today we're going to visit the exact spots where you can actually feel the planet's pulse.
Right? This is the default setting for us. The ground feels solid, it feels stable. It's just the stage for everything we do, every single day. Exactly. It's the background scenery. It's supposed to be dependable. And honestly, most of the time we don't give its own internal life a second thought. It's just there. And that is the huge question for today. What if the very ground we're standing on isn't some passive piece of scenery, but an active, dynamic character in the story of life itself? Okay, so when I say breathing, I'm not just trying to be poetic here. This isn't just a metaphor. We're talking about real, actual, measurable cycles of pressure and heat and matter that create these incredible rhythms all over the globe.
So this is what we mean by planetary breathing. It's the physical process. It's the planet literally inhaling and exhaling energy and matter. From the superhot mantle deep below to the highest clouds in the atmosphere, our world is in a constant state of give and take.
Let's start by going deep. I mean, really deep. Some of the most dramatic evidence of this breathing comes from the insane amount of heat and pressure that's just churning away, far, far beneath the surface. First stop, Iceland. This place is just geologically wild. It sits right on top of the Mid-Atlantic Ridge, where two of the Earth's massive tectonic plates are literally pulling themselves apart. This makes the crust super thin, basically creating these vents for all that internal energy to just escape.
And this is a perfect example of a rhythmic breath. Think about a geyser, like Strucker. Water seeps way down into these underground chambers. Then it gets superheated by the rock below, and the pressure starts to build and build and build until, bam, it's released in this massive, violent column of steam. It's a perfect cycle. An inhale of water, a pause, and then a crazy powerful exhale of steam.
Now, let's hop over to another famous hotspot, Yellowstone. And if you think of Iceland as a single vent, well, you got to think of Yellowstone as an entire lung. The whole park is sitting on top of this enormous magma plume, and it affects literally everything you see on the surface.
And get this, we can actually measure it. Scientists have used satellites to track the entire Yellowstone plateau, and it rises and falls by several centimeters every single year. It's breathing. It's inhaling and exhaling as that magma shifts below. This isn't just some neat fact. It's tangible proof of this colossal, restless power just sleeping right under the surface.
And this fiery breath happens in different ways all over the world. So in Iceland, the crust is spreading apart. But then you go to a place like Japan, and the tectonic plates are actually crashing into each other, with one diving under the other. That process is called subduction, and it creates this immense pressure that gets let out in these pulsing vents of volcanic gas. So you've got two totally different forces, but they lead to the same result, a breathing planet.
This even happens in the deepest, most alien parts of our world. We're talking kilometers below the ocean's surface. These things called hydrothermal vents act like chimneys, just blasting out superheated, mineral-rich water straight from the mantle. These aren't breaths of air, but chemical breaths, pulsing with the raw heat of the planet's core. So we've seen the planet exhale fire and chemicals from its core. But honestly, that's only half the story. Now let's come back up to the surface and see how these external forces, like gravity in our own atmosphere, create their own powerful rhythms.
So, welcome to the Bay of Fundy in Canada. This place has the highest tides on Earth. Twice a day, it's like the ocean takes a massive breath in, with water levels rising up to 16 meters. That's over 50 feet. And then, just as powerfully, it breathes out, rushing back to sea. This isn't just water sloshing around. It's a huge gravitational pulse driven by the moon, making this whole chunk of the ocean breathe in and out every single day.
All right, now for something way more subtle. In the Atacama Desert, one of the driest places you can imagine, the planet actually takes two kinds of breath. First, the crazy temperature swings from day to night cause the rock itself to physically expand and contract. At the same time, the column of air above the desert also rises and falls, creating something scientists call an atmospheric tide. So cool.
And of course, we have to talk about the big one, the most famous example of planetary breathing, the Amazon rainforest. This is biological breathing on a truly global scale. Every single day, that forest inhales a staggering amount of carbon dioxide, and in return, it exhales the oxygen that we all need to survive. But it's not just oxygen. The Amazon also breathes out incredible amounts of water vapor, forming these atmospheric rivers that literally dictate weather patterns thousands of miles away. It's just a powerful reminder that the health of this one place is crucial to the health of the entire planet.
So we've seen these fast, dramatic breaths and these daily rhythms, but some of the Earth's breaths are incredibly slow, playing out over seasons, or sometimes even thousands of years.
Let's go to Siberia. Here, the frozen ground, the permafrost, takes a very slow, seasonal breath. When it thaws in the summer, the ground actually sinks and releases methane, a gas that's been locked away for millennia. Then in the winter, it freezes and rises again. It's this slow, annual sigh that has some pretty huge implications for our climate.
Okay, now for a truly weird one. In some deserts around the world, you can actually hear the dunes singing. It's wild. As sand slides down the face of a huge dune, all the grains vibrate together, creating this deep, low humming sound that can last for minutes. It really feels like a deep, resonant breath coming from the heart of the desert itself.
Glaciers also breathe, but what's amazing is they do it on multiple timescales all at once. So on a daily basis, meltwater helps them slip and slide forward. Seasonally, they surge a bit in the summer and then slow down in the winter. But then on a millennial scale, as the colossal weight of that ice melts away, the Earth's crust itself slowly bounces back up. It's a process that's still going on from the last ice age. I mean, think about that. That's a single breath that takes 10,000 years to finish.
So we've seen geysers exploding, tides roaring, forests breathing. What does it all mean when you put it together? When we actually stop and listen to our planet, what is it telling us?
Well, it's telling us that the planet's breathing isn't caused by just one thing, but by this whole interconnected system of forces. You've got the internal heat from the core, driving volcanoes. You've got the gravitational pull of the moon, creating tides. You have thermal energy from the sun, causing deserts to expand and contract. And you even have life itself, biology, driving the whole system. It's all connected.
And that really is the big takeaway here. These things aren't just isolated geological quirks. They're windows. They're windows into the active, living system that is our planet. Earth isn't just a passive rock that life happens to be on. Its very dynamism, its constant breathing and flexing, is what creates the conditions that allow life to exist in the first place.
And so, that leaves us with one final thought. If we start to see the Earth not as a static rock, but as this breathing, pulsing, living world, how does that change things? How does it change the way we walk upon it every single day? It's something to think about. Thanks for exploring it with me.